Good morning, good evening, good afternoon, depending on where you are. Today is May the 2nd, and this is another of our bi-weekly SIG Apps call. My name is Mate, and I'll be your host today. We have a couple of topics for the discussion, but let's quickly go through the announcements. KubeCon EU 2022 is happening in roughly 2 weeks. We will be doing an update. I will be there personally. Ken and Janet will likely join us virtually. So if you want to say hi, I'm more than happy to hear from anyone that will be on KubeCon. As I said, KubeCon will be happening in 2 weeks. That also means that our next call on the May 16th will be canceled due to that. So we will see each other's in a month. And I haven't checked the date, so quickly doing that. So we will meet each other's on the 30th of May. I don't recall being there any holiday or anything like that. Okay, so Ken, do you have any other announcements that you want to add?
No.
Okay, so with that, we can jump over to the main topics of discussion. Replica set controller continuously creating pods failing due to syscontrol forbidden. Ravi and Philip, can you take it over from here?
Sure. Philip, you want to take over or you want me to?
Yeah, I guess we can both. So there is this issue which basically doses the cluster, and the problem is that kubelet is failing the pods on unallowed ccTLs, and replica set is creating the new pods in a loop, so you can get tons of pods created. For example, when I tried it, it was around 1,000 or 1,000 of pods in a minute. So, and like there are a couple of workarounds to this, but none of them are each workaround has some issues. So we would like to have a more comprehensive solution to this.
Yeah, so some of the things that are at this point of time are not clearly thought out are it seems every component is doing whatever it is supposed to do. Like, for example, kubelet says, I'm rejecting the pod because the sysctl does not make sense to me. And scheduler is not aware of that. So scheduler cannot do anything. And the replica set controller is supposed to create pods if the desired does not match the actual number of successful replicas created. So every component seems to be doing whatever it is supposed to do. But the missing piece here is, say, if the node can actually advertise in one of its status conditions that this is a sysctl that I'm not going to use, perhaps scheduler, or the other option is the node lifecycle controller, which actually can look at the conditions of the node, can say that I'm going to taint this node with a particular taint, and the replica set controller would create those pods, and the pod will be in pending state instead of in a failed state, because of which we are in this state now. The other option, which is slightly related to this, is to have back off within the controllers. And I think, Ken, you have mentioned in the past that you are concerned that controllers should not have any knowledge of the conditions based on which they will back off or something like that. So what I'm thinking of is, can we keep back off as a separate thing from the issue that we are facing and have the back off irrespective of the conditions that we are seeing?
So you want a generic back off on pod creation failure?
Yeah, that is what I'm thinking of. And the second condition would be something like whatever I have explained earlier, which is the kubelet would specify that there is an unsafe sysctl and the container can cross the boundary, and the node lifecycle controller can actually taint the node, and we do not have to touch anything in the scheduler.
Can you repeat that proposed solution again?
Sure. So what I'm thinking of now is, like as of now, this allow unsafe syscuttles is something that is specific to kubelet, and only kubelet has knowledge of the pods that are getting failed. And that information is not getting passed on to scheduler or the controller.
You want to add it. Well, okay. There are two, like the controller doesn't know anything to back off as far as it's concerned. It's doing valid pod creation. It's not concerned with placement, right?
Yeah.
So like it can't be preemptive. It can't say, okay, well, I'm going to examine all the nodes. And actually for this information, because like you just said, it's not surfaced via taint anyway. We wouldn't even know that the taint was available. From the other side, the scheduler, again, because it's not surfaced as a taint, doesn't know not to place it there. For this particular instance, it would, to me, what would make sense would be the same thing as like if you were dealing with a scarce resource where you would put a particular taint and have a toleration so that the scheduler knows how to do the right thing using kind of the existing framework for doing that, right? So like, I mean, but that would kind of push it to the end user, right? Like, because the user would have to, if they wanted to use this feature, declare a toleration for the taint of syscuttle available, right? Which, and maybe that's not an awful thing. But to do it at a controller level for actually detecting every use case, it's going to make it super hard for anyone to write controllers at that point. Aside from just the built-in ones, if someone wants to write a custom controller, that's non-trivial.
Yeah, I'm not saying that.
If we wanted to do a generic backoff as a library and kind of make it generally available, I mean, that might be something that's tractable. Like from a controller perspective, and I realize like from the perspective of controllers, I wanted to make it as easy to write a custom controller and maintain that controller as possible, right? So like any other requirement that we place on, like, okay, now you have to be concerned with backing off. If we're going to do that, I want the on-ramp for that to be smooth for anyone who's going to write a controller, and I want the maintenance of that to be super easy, right? And like, I want it to be a clear win. So like, if we're going to align that generically doing back-off detection on failed pod creation is something that we want all controller authors to do, I think that's something we need to make easy. I just don't know how easy that is to do in the general case, right? Like, how do you know? So what would be the signals that we would use for backing off? Just pod creation failure? Because pod creation failure could be like all of the nodes in your capacity are down for right now, and we're going to back off creating pods in that case, and that's not the end of the world. But when the nodes come back up, we'll start creating it. Or you've pushed out the capacity, right? There's no more places to put a node, right? So like, it's not a trivial thing to do to say like, we're going to detect cases in which the scheduler is failing on placement or kubelet is rejecting admission to the node, and then try to back off there. Like, it's not, I just don't see a very like straightforward implementation that we could make generic across all the controllers and push out. And I think like Matt said, you know, like there are cases where we do this for daemon set in particular, but, or no, Jordan, I'm sorry. But in those cases, it is very like, you know, you have one pod per node and it's very clear about why the rejection happens. It's a special case, but it's a special case problem. Like I'm not opposed in general to the approach of implementing backoff. I just think we have to be careful about how we do it, especially because the controllers are V1 and we don't want to implement unexpected behaviors. So like if there's a proposal, we have a general proposal about how we think we can do back off in a way that's backward compatible and that's reasonable for a good set of use cases and approachable for developers both inside of core Kubernetes and in the larger ecosystem. I wouldn't be opposed to that. It's just like I haven't seen that proposal yet.
I mean, the biggest issue is that normally we do have a backoff, but the backoff in the controller is coming from a direct failure from a pod creation. So, or any kind of updates to the API, or basically controller invokes any kind of API call, whether that's update, delete, or creation. If that fails, yes, we do back off and we will because that's a direct information that we can actually, we as in controller, we can work with, and then we can respond to the current situation and eventually figure out, oh, the API is either overwhelmed or is not responding or something else is going on, and we can slow down our request. The problem with this one is that the actual failure is outside of our controller. Although at the same time, as Philip mentioned, he observed 1,000 creation of the same pod. Hard to say that it is exactly the same, but I wonder if it's possible somehow reasonably identify, oh, this replica set is having another pod created again in a very short time span, which might seem somewhat suspicious, and based on that, try to create the backup. But I guess, like you said, probably some kind of a generic mechanism will be the best option for us to have, because it will basically apply equally across the board for most of the controllers. Although they, well, not necessarily. The ones that are directly creating pods where they have closer visibility to what's going on in the
I guess
in the cluster. But
like you just said, right? Like if we're going to back off because of API failures for pod creation, like you said, it's a clear signal. What's the signals that we would use for scheduling placement failures or node rejection? Like what signal could we possibly use to back off reasonably there, right? Because it's not something that it's fairly opaque from a controller perspective.
Yeah, the worst part that that worries me the most is that, first, not to mention the fact that this issue is from 2019, is the fact that it's hard for us to figure out how to properly respond. But at the same time, this poses a great security risk. Well, kind of, because you can quickly overwhelm your cluster by just creating a simple replica set with forbidden syscontrol, which is, yeah, well, kind of, we will prevent your pod from running, but still the controller will create 1,000 pods within a minute, and, well, it's hard to react in this busy cluster. Yes, of course, you can have monitoring and all that, but for that short period of time, when you will actually notice this this craziness, it'll take some time. Maybe the generic backoff is something that we should be thinking in the long term.
I don't disagree with that at all. Like my thing is more about how should we do it, and like I guess so instinctually, right? Like my thing is, if the API machinery is allowing us to make 1,000 successful pod creation requests, you could fix that on the client side, but that seems to me like a resource exhaustion on the server side. Like the machinery should protect itself, not just in that case, but in the general sense. And if the problem is that like we're scheduling pods in a location where they can't possibly run, and the controllers aren't responsible for the scheduling mechanics by design, trying to make them responsible for the scheduling mechanics also seems like somewhat of a non-goal to me, right? And I think the issue is kind of sticking around because like there's a little bit of, well, you should do it, you should do it, you should do it. It shouldn't be a scheduling problem. It shouldn't be. But if my concern about making it a controller problem is now like, so like the people in Argo, now they have to go do it, right? Like everybody who writes a controller that deploys workloads or deploys pods now has to worry about this problem. And it seems to kind of break the Unix philosophy to me, right? Like solve the problem once, solve it well, and make it generally available. If we feel like the right way to do that is via a library that we distribute to the community at large and then leverage inside of the built-in controllers, that's a path forward to me. It's just like, if that's what we're going to do, I go back to, again, what are these signals that we're going to base this library on to achieve a reasonable behavior that's both backward compatible and generally useful? And looking at the problem, none of it still seems clear to me. Like nobody, like I don't see like, well, how do I detect that this is a case where I should back off? The API machinery is telling me go, go, go. If you're asking me to throttle based on successful requests, I don't know, like that's, we could put in generic timers that say like the max threshold for total creates coming out of a controller is this, and we'll back ourselves off. But that introduces behavior that might be undesirable from like, blocking rollouts and making rollouts more slow for large, like for people who have very large deployments or who have very, very many deployments, globally throttling and globally rate limiting the replica set controller or deployment controller is going to be a problem for them.
Well, that's actually something that is already available because the PNF, and I can't remember what PNF stands for, which is basically the mechanism present on the API server where you can limit the amount of requests per client. Priority and fairness, that's the full name. So we have that mechanism, and the cluster administrator can theoretically create global queues and somehow limit the built-in controllers. So there are options. I'm more concerned about, the default approach and the default what we have, because like Philip and Robbie mentioned, there are options because you can quota, although it doesn't have, it can't be a, it has to be a specific quota type to be able to cap at all the pods failed and succeeded, so that the quota counts all pods, not just the running ones. Because in the normal case where you specify pods, if I remember correctly, that case is described there. I think Jordan put it there. It will only quota the running pods, but if you specify that with pods count, if I remember correctly.
It is counts.
Yeah, that will actually work, and it will stop because it will. Yeah, that's the one. With the hard count pod, that will stop the controller from creating this many pods because it counts all the pods, not just the running ones.
Signal for this one is like that the once you create the pod, it like the phase goes to fail, and I think as Ken said, the problem is that like this is the scope of this is very generic. So even if you have some replica sets which are failing in some % of number of cases, now your replica set will get much slower because of the backoff, even when it is like behaving properly, like from the customer standpoint. So would this make sense, like to discuss some like really generic like default behavior and have some like configurable options for the backoff?
Yeah, I think what I want to mention is there are two different set of problems, right? I mean, the first problem that we have is having generic backoff, and how to implement is the first problem. The next problem is, would backoff solve our problem? Say if it is coming from Node, how do we detect and special case certain things, right? Which we do not want to do in the controller. The problem here seems to be that Node does not have a condition which either scheduler or not the replica set controller. By that, what I mean is any workload controller. It should not have any say in the recreation rate based on the failure state of the pod on the node. Rather, it should be something like once the kubelet fails those pods, kubelet should have a condition on the node object which says the node is actually crossing, or the pod is actually crossing the boundary that we have specified for the node. And the node lifecycle controller can tell that this particular condition exists on the node. It would be similar to memory pressure on the node or disk pressure on the node. And the node lifecycle controller would paint that particular node. We do not have to touch anything in the core workload controllers apart from having backoff. And the workload, if the user want to tolerate that particular taint, they are responsible for having a toleration in the workload saying that I can tolerate it. I would like to go ahead and get scheduled on the node, or where the workload can cross the syscuttles that we have specified or the boundaries that we have specified. So I'm not talking that the workload controller should have specific failure conditions based on which the creation rate should be controlled. Rather, the node should specify something, and the node lifecycle controller or some other entity should say that the node has certain problems and I'm going to taint it. And if you want to use it, go ahead and use it. Does that make sense? I think I should have been clear earlier. That's what I was trying to say.
I'm not convinced that the taint is the right solution, because what if you have pods that basically can run anywhere? I mean, pods that don't require this ccTL. Then those pods would have to be tainted for these nodes that
That's a good
disallow.
point. You mean they'd have to have it, like any pod who wants to run on the node has a toleration, and the configuration from a user perspective really isn't implying that, is it?
Mhm. So
Yeah.
I guess the only tool we have is rather no labels and selectors. The pods that are using this feature should be pointing to the no label that that means that this node has this ccTL calls allowed. But then it's pretty much on the user to configure all of these things. So I'm kind of falling into the idea that, yeah, maybe we should just have the back off, and we just need to detect the reason why a pod was not admitted. Because we already have backups for jobs, and it's based on the. It also pays attention to the exit code for the containers. So I don't know if there is an exit code from this, or what's the status of the pod once it was rejected. So I guess that would be the signal, the kind of generic signal that we use from the pod.
I don't think you're going to get a SIG signal back, because I don't think the pod ever gets. Does the container actually launch?
No, I don't think it actually launches.
Going to get a bunch of fails, right?
It should at least have a failed phase. But
Yeah.
what else is there? Like, is there anything else we can use as a signal for backups? Because in jobs we actually use the termination status. I don't know. I don't remember exactly what, but we somehow use if a pod failed, we use that information for backing off. So I guess we will have to do something similar. This is just to protect the control plane, right? It's not about whether the pod should run or not.
Yeah.
In this node. I think that unfortunately that has to be on the user to configure properly, because taints that don't provide the semantics.
Yeah, so one of the reasons that I propose taint is, or two reasons, is it will be in line with what we are doing for other node conditions. Number two is we have this default tolerations plugin in Kubernetes, where we can specify what are the default tolerations and what is the time that we can specify, which is an admission plugin. So that is why I thought, okay, if we want to have something like that, either user can explicitly specify or we can have a default toleration. Like, for example, in daemon sets, we provide the default tolerations for certain taints. So that is one of the reasons that I've gone with this approach. I'm not saying that taints are like the best ones, but my main goal here is not to touch anything in the scheduler and not to touch in the controller, because if we touch something in the controller, we may have to keep track of all the conditions which can actually lead to back off. So that is, doing that generically is hard is what I'm thinking.
Have you brought this up with SIG Node at all?
Yeah, so I think Derek has mentioned, like, I think he has responded to one of the questions, like one existing mechanism on the kubelet side to have this kind of condition is, I forgot the exact name, but they have one mechanism for which or through which they can say that the pod is not going to be in a hard failure stage, meaning it will be in a blocked stage or some other stage, but not a hard failure. And the pod will be in pending state, and the pods would not be, the further pods would not be created. But Derek is not in favor of having a soft failure, but rather he wants a hard failure to happen on the kubelet side. So whenever we have this hard failure, this is bound to happen where we are going to create as many pods in the controller unless we have some logic which says, I would like to back off and then create.
So I guess like the thing I'm still trying to think about at a higher level is this. Here's what the customer is saying, right? Like, okay, I deployed my cluster and I configured all of my kubelets to not allow unsafe syscuttles. And then either my previous deployments that I have somewhere else that I'm going to apply to this new cluster, or these new deployments I'm making are going to try to run these syscuttles and they're going to get rejected. So like one of two things is happening there. Like either I misconfigured my cluster when I turned it up, or I don't really understand the nature of my cluster configuration when I'm trying to deploy my workload. And it's because this is a parameter that you're passing to kubelet on node turnup, it may not be clear to the user what the operator has actually configured, right? So there's a mismatch. And then because there's no node in the cluster that you can actually run this pod on, the scheduler is just going to keep trying to throw it around and like leave out other taints and scheduling predicates that may be attached to the deployment, but it's never going to be able to schedule it. If we add back off here, how is the customer actually, like, what is the impact that feature would have versus the cost of implementation? I guess is kind of my thing, right? Because it does seem like there's not a broad consensus on like, there's this great generic signal we could use to to implement a backup off of that would solve this case. And even if we did, this workload is still misconfigured and the customer's never going to be able to run it. Right? Like there's basically, like, to me, the root problem seems like we have this feature in kubelet that it doesn't communicate its expectations or surface it in a way that the consumer of Kubernetes, like the developer who's deploying it, can reason about. And whatever we do here isn't going to fix that problem.
So if we just implement backoff, I think it does not solve the problem, but it actually reduces the time by which the customer is going to hit this particular problem. So that's why I told backoff is not a complete solution to it. Like eventually the cluster state may reach that stage where it has got 1,000 pods or n number of pods which can break the cluster. But having backoff would increase the time by which the cluster admin is going to hit that state.
And it will give the user time to react to this, because you will get the replica set failure and you can see something is wrong.
Yeah, that's another point.
I don't think we will be able to close the discussion on this topic here. There are a couple of follow-ups that need to happen before we can revisit this topic. So probably let's wait for the discussion with the SIG node to happen. in the first place. The generic backoff is definitely on the table, but like I said, is not the won't solve the issue for sure.
Yeah. I also personally would like to better understand the intended use of this feature. Like, because one thing that's not clear to me, like just a priori, is it ever, so, okay, does SIG node intend for there to be mixed mode clusters where some nodes are configured with a kubelet that has this enabled and some nodes are not, right? That would be one question I would have right off the bat, because then back off is pretty much what you would not want to do. Like if it fails to schedule, you'd want to schedule it right again, because eventually you're going to get it to a node where it works, right? Like what was their intent? What is the intention from the SIG node side of interaction with higher level controllers? And yeah, I'd like to get their opinion on how they see this feature interacting with scheduler and with controller, especially before committing anything on the SIG app side.
Yeah, I think it makes sense. So one thing I have heard from Signode, and I have pasted whatever Derek was mentioning last time in the chat, is he wants the failure to happen immediately and it should be a hard failure. At the same time, it's a flag on the kubelet side. So some of the nodes are going to have this particular feature enabled, some of them are not going to have this feature enabled. So like, how can we solve this problem at the controller level using backoff? I think backoff may solve some part of it. It's not going to be a complete solution that we can look at.
To me, if that's the intended use case, right? Like if the idea is that I'll have a mixed mode cluster where I have a set of nodes that I'm going to allow, these are basically like somewhat unsafe nodes where I'm going to allow code to run that has syscuttles that I consider to be unsafe based on a security context. And then I have a whole other set of nodes where no, that's completely not allowed. Then it is a scheduling problem, right? Like the scheduler should be, if that's the intended use case, I would argue that the scheduler should be aware and solve it up front, right? Like you should, the scheduler's, okay, well, this has unsafe syscuttles. I have this amount of capacity where I can run that. I'm going to put it there. Or I'm going to keep it in pending because I can't even launch it because I don't have enough resources to actually schedule it there based on the resource limits and requests. And if it's not, then like that is a scheduling problem to me, right? But if that's not the intended use case, then maybe we should, maybe then is the time to think about the problem differently, in my opinion.
Yeah, that makes sense.
I agree that it's more of a scheduling problem, but I guess we just need to come up with the correct way to surface it. Because I imagine there are a few other node characteristics that are not visible to the scheduler. This is just one of them, right?
Yeah.
So we need a maybe even a new API to signal. I guess we have tolerations, but if we go the tolerations path, then we need a mission controller to add taints to everything, or yeah.
Yeah, like how it can be implemented in scheduler is something that we can think through. But I think all of us agree that there has to be some condition on the node which actually represents the state. And I think Derek is fine with it. Like when I spoke to him, Derek told that, yes, we can actually surface it as an API in the status. And whether scheduler would actually look at it and then place the pods, or if the node lifecycle controller or some other entity can use the existing scheduling mechanisms like taints and tolerations or affinity or something, we can discuss about that later.
Yeah, maybe. Yeah, I guess we can bring this discussion to SIG scheduling, but
Yeah,
just thinking quickly, I think maybe the admission should set a node affinity, and then the node lifecycle would add this label to the node. That's a mechanism we have today, but I'm not aware of any existing admission controllers that are adding affinities. I might be wrong, but
yeah, I think.
Go ahead, Rick. Sorry.
Yeah, so I think one thing I can get started on is come up with a design document in 125, have the discussion across SIG nodes, SIG scheduling, and SIG apps. And then I think we can go from there. So part of the thing that I wanted to bring up here is, would the generic back-off mechanism be helpful, irrespective of whatever we choose for solving this problem? I think that is the thing that I wanted to bring up. But I think Ken says it may be useful, but there are no use cases at this point of time, is what Ken is saying. Correct me if I'm wrong, Ken.
I'm just, if we're going to do something that broad in scope, that's going to kind of penetrate all the built-in controllers and then everyone else who's writing a community controller that leverages it, I just want to make sure that, like, I mean, we could do it out of tree and kind of test it and like validate it and do it slowly. Like, we don't have to rush into it and do it tomorrow. And there are ways we can get validation that we're doing the right thing. But I guess, like, given that the API machinery, like, if what we're trying to do is to protect the API machinery from being overwhelmed by requests in the event that we hit a controller tight loop, there are mechanisms that the API machinery has for doing that, right? So is the right thing to do to try to build effectively an SDK or some type of library client side that we distribute across community, or can we leverage the existing features with respect to queuing and fairness in the API machinery to ensure that we don't overwhelm it from the door, right? Like, is there, I think, like, understanding, like, from the API machinery side, is this what they would recommend that we do, would be informative, right?
Yeah, makes sense.
Maybe that will be also another reasonable venue to discuss this issue with, since API machinery is usually affecting all the areas. So they could be also, the topic could be brought up for one of their next calls, and we can hear their general opinion. I think would be a reasonable approach. Okay, I think we have sufficient follow-ups on this topic. Not sure we have the person behind this, the next topic, but it looks like this is just a PR that has been there for quite a while. I remember that it's been on my queue for a little bit. I see Aldo already commented on it. I'm planning to have a look at it later this week. Sorry for it. Apparently, it just slipped through the cracks in my queue. Not sure if the author wanted to hear anything more than that. Okay, are there any other topics that folks wanted to discuss?
If we still have time, I can comment a little bit on this issue.
Yeah, go ahead.
I think I thought this could have been a bug, but wasn't aware of users hitting it. Basically, when you use how's it called, queue after, it's not necessarily gonna queue after. If you queue earlier, let's say I say queue after 5 minutes, and then another queue comes and it says queue now or queue in a minute. That queue in a minute is the one that's going to happen, and queue after 5 minutes, that's going to be ignored. It basically is disappearing, and that's the bug here. That we are only queuing after for the TTL or active deadline. Sorry, at the job, the first time we see the job. So I think that the easy solution is just queue after every time we sync the job, because every time we sync the job, we already got rid of the older queue after. So I think that would be my proposal, and I think this PR is way too complicated for the reasoning, the reason for this bug.
Oh yeah, if this is about, I can't remember if I looked at it earlier or not. But if this is about the active deadline seconds, and we only queue after once, it is true. I remember that very well. That the at after, or generally the queue works such that it will pick the one that is closest to be executed. So if you add the same resource twice, the one with the shorter time will be picked, will be acted sooner, and the other disappears because it doesn't keep two values. Because we are heavily using that mechanism for the schedule for cron jobs. So yeah, I definitely agree that having whenever the active deadline second is set, we should be calculating the delay between now and whatever is left with the active deadline seconds, and always ensuring at the end that we will requeue this job after some time. Because I assume that the problem is basically coming from the fact that somebody created a job with a active deadline seconds, then I don't know, perform a modification on it or something like that, and that caused the active deadline seconds to not be calculated properly, more or less. But yeah, I'll have a look at it. So, but I do agree about the general sentiment.
The reason why I didn't bring this up before when I read the code is because we always have pod status updates coming from Kubelet.
Mm-hmm.
So in general, like those queues should be enough to somehow match the active deadline seconds. But I don't know, maybe the Kubelet is being slow, or
there are some edge cases when this can happen, and I can't remember what were there, but the solution was to use the add after, which will always ensure that we will recheck the job at whatever the time is to complete the overall execution. Okay, Aldo, I guess you'll comment on the PR. I'll have a second look at it later this week as well. Does anyone else have any other topics that they want to bring up? Yeah, go ahead, Biff.
Hey guys. Just wanted a quick question about the status of the SIG Apps and SIG CLI reviewer mentoring club. Is that still happening?
I need to double check with Paris. I haven't heard from her. I remember she was supposed to create a list for us, and then we would follow up with the two groups, which will be one for people that are not yet Cube contributors or Cube org members, because those people will require a different set of preparation and different set of guidance. And then the separate list of folks who already are past that requirement and will require more guidance around the actual reviewer and preparation towards that. So I remember that somebody already recently pinged me on Slack with regards to this. I'm hoping to ping Paris later this week and resync with her where we are and with Eddie, and bring it back to the actual motion. Given that we will be having KubeCon in roughly 2 weeks, it might slow down a little bit since a lot of folks will be preparing for that. I'm hoping to, in the worst case, I'll follow up with Paris during KubeCon, and then we can return to this sometime in June, in early June.
Okay, that sounds good. Thanks for the update.
Sure. Okay, if there are no other questions, I think we can close the call at this point in time. Okay. Thank you very much, all. Enjoy the rest of your day. Take care.
Thank you. Hopefully see you in KubeCon, some of you.
Thank you.